Hi, Integrated Math 1. Welcome to lesson 4.1.3. We're going to compare data sets. Yeah, we're just comparing our stuff. So we've done a lot of work with dot plots and histograms and box and whisker plots. We've played with measures of central tendency and measures of spread. We've looked for outliers. Done all kinds of things. We're magical and amazing. Today we're going to push it a little further. We're just going to compare. We're going to compare the standard deviation of data sets, right? We did a little bit of that last time. We're going to analyze and interpret data graphically and numerically. Like, that's great. What does it mean? We're going to determine which measure of central tendency and spread is the most appropriate to use. Is it better to use the mean or is it better to use the median? We've talked about that before. And if we're using the mean, we should be using the standard deviation for our spread. If we're using the median, we should be using our interquartile range for our spread. So yeah, just when should we be using what? Right, that's the thing. So you know how to determine the most appropriate measure of center and spread to describe a data set based on its distribution, right? If it's skewed right or skewed left, we should be using the median, so we should also be using the interquartile range. If it's symmetrical, we should be using the mean, which means that we should be using the standard deviation to describe the spread. So how can you use this information? We've talked about this before. How can you use what you know to compare data sets in problem situations? And we're going to start with stats on cats. Oh, that brings me joy. So page M4-36, let's talk cats. I like this. So the Humane Society records the number of different visits from potential families, a sample of 25 cats from each of their 2 locations received before being adopted. So how many visits did a kitty get before they went to their forever home? Oh. The box and whisker plots display the collected data. So you can see I've got the north center up top, the south center on the bottom. Now, here's the thing. Yumi, Mia, and Sloan are trying to determine which shelter's cats receive fewer visits before being adopted. Yumi says the mean and standard deviation of the data for the North Center shelter should be compared to the median and IQR of the data from the South shelter. Mia says the median and IQR of the data from each shelter should be compared. And Sloan says the mean and standard deviation of the data from each shelter should be compared. Who's correct and why? So Yumi says use one of each for each one. Mia says we should use the same for both shelters and it should be the median and the IQR. Sloan says we should use the same for each shelter and it should be the mean and the standard deviation. Who's right? Hit pause, jot down your thoughts, hit play to check your work. So right away, I'm sorry, Yumi, I'm going to say no. Yumi, that's a terrible idea, right? You can't compare different sets of data. That doesn't make sense. You can't compare different measures. So it has to be Mia or Sloan. We need to decide, look, either we do the mean and standard deviation for both, or we do the median and IQR for both, all right? We can't do this whole like back and forth thing. So I'm going to come over here and I can see that while my North Visitor Center is pretty symmetrical, my South Visitor Center is not. It is skewed right. There's a value here off to the right that's like pulling on it, right? This value off to the right that's yanking on it and skewing it right. Because it's skewed, we need to use the median, and that means we need to use the interquartile range, and we need to do it for both of them to be comparing the same measures. So Mia's on it. So because the distribution for the data for the South Center is skewed, we've got to use the median and interquartile range. If even one of these is skewed, you've got to use the median and interquartile range. And you have to compare the same statistics, right? You can't do different statistics for different things. That doesn't help us. We have to compare the same stats. So let's find the median and the interquartile range for both of them. And that would be a good way to compare. Now that you have that in your head, let's come back to Miss Webb, our spelling bee coach, right? She has picked her team. We've decided that. But she's preparing for the first scrimmage, and she needs to determine which student should be the spelling bee captain. The top 2 spelling bee students' scores are recorded in the table. So these are her top 2, Maria and Heidi. These ladies got skills. Miss Webb analyzes the score, and what she does is she calculates the approximate mean score and standard deviation for each unit, for each student, I should say. So I would like you to advise Miss Webb whom she should choose to captain the spelling bee team. You're going to have to do some math. You're going to have to find the mean. You're going to have to find the standard deviation for each gal, and then decide who's captain. Go ahead and hit pause. It's going to take a bit of work, and then hit play when you're ready to check your work. Well, I think I should have been the spelling bee team captain, but apparently it's not my call to make. It's Miss Webb's, and she's deciding between these ladies. So first of all, she did say the data is pretty symmetric. She said we're going to use the mean and the standard deviation. Miss Webb did say that. So let's do this. I calculated Maria's mean. I added them all up. I divided by how many there are. And I found out that Maria's mean was about 82.93. So we're going to start with Maria. Maria, I just met a girl named Maria. So Maria's mean was about 82.93, which is pretty good. Now, I then went through and I did the standard deviation. It was a lot of work. So I subtract. Remember how we did that? We subtracted everybody. And then I added them all up. Oh my gosh, that was a lot of work. Oh, actually, before I added, I subtracted everybody, and then I squared them all, and then I added them all up, and then I divided by, oh my gosh, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I divided by 15 minus 1, which is 14. And then I did the square root. Oh my gosh, it was so much work. And I found out that Maria's standard deviation was 10.61. Hopefully you got something close to that. And then Heidi. So I dealt with Heidi. And I was like, all right, Heidi, I added these all up. I divided by 15. And I found out that Heidi's mean, Heidi is not mean, but her mean was about, again, 82.93. Also, same as Maria's. Whoo, so we better check the spread. So we're going to check her standard deviation. So I subtracted all of these, 82.93, subtract that from all of these, squared them all, added them all, divided by 15 minus 1, which is 14, did the square root. Oh my gosh. And I found out that Heidi's standard deviation is 16.75. So guys, who should be the spelling bee captain? Well, I'm looking at this, and their means are the same. That's not going to help me decide. So I want to look for the gal with the lower mean, because we said that means they're more consistent, right? Lower standard deviation. A lower standard deviation means there's less spread. It's more consistent around that good score that we like. Maria has the lower standard deviation. Maria should be the spelling bee team captain. They both have the same mean, but the standard deviation for Maria's scores is smaller than Heidi's. Maria's more consistent. She just is. Don't you hate it when your flight is late? It drives me crazy. So now let's compare some airlines. Data were collected from 2 rival airlines, measuring the difference in the stated departure times and the times the flights actually departed. So it was supposed to leave at a particular time, and this one left 14 minutes later. This one left 7 minutes later. Check it out. This one left 49 minutes later. Oh, I hate it when that happens. The average departure time differences were recorded for each month for 1 year. The results are shown in the table. So here we have My Air Airlines, right? This is how, oh, look, we did a flight on time. Whew, check that out. We had a lot of late flights. Fly High Airlines also had a lot of late flights. Oh my gosh. So you're scheduling a flight for an important meeting and you must be there on time. You must be there on time. Which airline would you schedule with? Make sure you back it up with some numbers, people. Hit pause, make your decision, do some work, hit play to check your work. Now, if you went to all the trouble to put this data on like a, forget a box and whisker plot, just put it on like a dot plot, you would have seen it's pretty symmetric. It's pretty symmetric. So since it's symmetric, I'm going to find the mean and the standard deviation. I did a whole ton of work in that few seconds that you waited, or maybe I did it ahead of time. So I found that the mean of My Air Airlines was 21.33, and the standard deviation was about 11.83. And then I did the same thing for Fly High Airlines. I found the mean and then used it to get my standard deviation. The Fly High mean was 24.67 and the standard deviation was 12.86. You know, I'm looking at this and I can see that My Air Airlines, not only did it have a lower mean, which means it was, you know, more likely to, the center is closer to the actual departure time. The standard deviation was also lower. It was also more consistent. So I'm going to reschedule my flight. I'm going to schedule my flight with My Air Airlines. Absolutely, I am. It had a lower mean and it had a tighter, it was more consistent. It had a less spread. It had a lower standard deviation. Yeah, My Air Airlines. Y'all winning. Let's compare garages. Brenda needs to get the oil changed in her car, but she hates to wait. We all do, Brenda. We all do. Quick Change and Speedy Oil are two garages near Brenda's house. She decides to check an online site that allows customers to comment on the service at different local businesses and record their wait times. Ah, convenient, right? Brenda chooses 12 customers at random for each garage, and the wait times for the garages are listed below. So, based on the data gathered, which garage should Brenda choose if she's in a hurry? Hit pause. See what you can do with this. Do a little bit of math, a little bit of numbers, decide where Brenda should go, and then hit play to check your work. So I don't know about you, but when I looked at this, I noticed like the numbers are pretty consistent. Oh, cred. There's like a 60 in there. But I saw a similar issue with Speedy Oil, like kind of consistent. I saw like a freaking 85. We've got some numbers that are skewing our data. We got some extreme values skewing our data. This means, since my data is skewed, we're going to have to use the median and the interquartile range. So remember to do the median. You have to line them all up in order and pick the one out of the middle, right? So I did my 5-number summary. I lined these all up in order, minimum, maximum, pick the numbers out of the middle. But then I did the middle of the upper half, middle of the lower half to get my interquartile range. I found my median was 19. That was the middle number. My interquartile range was about 7.5 when I subtracted my quartiles. For Speedy Oil, my median ended up to be 36. Whoa. And my interquartile range is 22. Oh my gosh. Speedy Oil has a larger center and a bigger spread. Oh no. Quick Change is the better garage if Brenda's in a hurry. Now, I don't know if they do a better job. I just know they're faster. There can be other problems there, right? But if Brenda's in a hurry, Quick Change is the place to go. The median was lower and they were also more consistent, the interquartile range, though they had less spread. Definitely the way to go. Oh my goodness. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, let me know. And I'll see you guys soon. Bye.